What if I tell you that someone may have already discovered aliens using their home computer or personal phone? What if a detected signal from an actual extraterrestrial intelligence society is hidden deep inside large amounts of collected data? Scientists that search for extraterrestrial intelligence collect billions of signal detections that come from space with the hope that an ET message is buried in all that data. Our antennas and radio telescopes receive an unimaginable amount of signals every day, every second. And unfortunately, all the computers in the world are not enough to process this data. What if I tell you that millions of people volunteered their personal devices, including their home computers and even their smartphones, to help with this monumental task? Hello, I'm Dr. Alejo. Today's video makes me feel very nostalgic and old. At the start of my 20s, back in 1999, and probably while watching the X-Files, I heard about this awesome screensaver developed by the Search for Extraterrestrial Intelligence SETI Institute. As soon as I heard about it, I knew I had to get it. But it wasn't its awesomeness or the fact that it was developed by the SETI Institute, probably my favorite organization in the whole world, in case you haven't noticed. The reasons why I wanted to download it and install it on my Windows machine. The real reason was that, potentially, by running that screensaver in my home computer, it was a real possibility that my device would help finding aliens. Do you need any other reason? Join me to learn about the SETI at Home project and the latest results presented in this year's International Astronomical Union Symposium advancing the search for technosignatures. Did someone's computer find aliens? Before we dive deeper, don't forget to like, subscribe, and press the bell icon. It really helps the channel grow. Let's jump in. For those of you that are too young to know what a screensaver is, this was an animation or an image which was shown while your personal computer was idle for a designated period of time. The purpose was really to prevent your monitor from being damaged due to individual pixels being on for a long time. However, most modern LCD monitors don't suffer from that condition, and screensavers are not as popular as they were a while ago. Home computers, and more recently smartphones, are idle for a long time, doing literally nothing. On the other hand, SETI scientists had an incredible large amount of data waiting to be processed. Therefore, SETI researchers saw an opportunity here. With the help of a group at the University of California, Berkeley, led by David Anderson, who also led the project SETI at Home at the Berkeley SETI Research Center, developed the software platform Berkeley Open Infrastructure for Network Computing, or BOINC. The idea was to allow researchers to take advantage of the processing resources of personal computers and other devices around the world. The idea was simple. Observational data collected by the now retired Arecibo telescope in Puerto Rico was then sent using regular postal mail to Berkeley on disk drives. Once in there, the data was divided in both time and frequency domains in work units of 107 seconds in duration. These work units were then sent to home computers that installed the SETI at Home screensaver. In the background, and using the resources of the device, the program was trying to flag anything that could look like an artificial narrowband signal, pulsars, or repeating patterns. Specifically, the SETI at Home data was collected using the alpha receiver from the Arecibo telescope. The frequency band was 2.5 MHz around the 1420 MHz frequency, or the hydrogen line, which is commonly used in SETI searches due to its importance in the universe. Hydrogen is the most abundant element in the universe and is considered by SETI strategists as a possible natural meeting frequency for any advanced extraterrestrial intelligence. This frequency is part of the common Warhol range, which goes from 1420 MHz to 1720 MHz. In fact, I explored this idea in much more detail in my book, Story of More Than 5,000 Worlds, where I explain how scientists choose where and how to search for extraterrestrial signals. I invite you to check it out. The alpha receiver could observe 7 different patches of the sky at once, In addition, the receiver would detect different orientations of radio waves. It had a very narrow field of view of 0.05 degrees. This would allow the researchers to pinpoint the source from which an interesting signal was received. During the observation, full coverage of the sky visible from Arecibo was achieved. But SETI at home also had data from other radio telescopes, referred to as commensal observing. It piggybacked on other astronomical observations. While astronomers were studying galaxies or pulsars, SETI was quietly scanning for alien signals in the background. The algorithms running on the home computers were essentially searching for three types of signal. The first one was continuous narrowband signals. Narrowband signals transmit information on a fixed frequency, so it is easy for someone to receive and decode the transmitted signal. This is how you used to listen to radio stations a while ago. The second type of signal the algorithm was looking for was pulsed narrowbands, essentially signals that turn on and off, which could indicate intentional communication or modulation. And the third type of signal was arbitrary repeated waveforms, complex patterns not necessarily easy to understand, but that repeat, which could be an indication of encoded information. The data was collected during 14 years, from 2006 to 2020, but the project itself actually began earlier, in 1998, with initial observations at Arecibo. During the first stage, or front-end stage, about 12 billion signal detections were identified from a total of 1.2 petabytes of data, using specific search algorithms. So, after processing billions of signals, how do you actually find something that could be alien? In the second stage, or back-end stage, specialized algorithms identified and discarded signals that were the result of human radio frequency interference, or RFI. This is everything that seems to be human-generated signals, things like TV and radio broadcasts, radar systems, cell phones and communication networks, satellites, such as those used for GPS and now by services like Starlinks, and even everyday devices, for example, microwaves. After removing random noise and human interference, the algorithms also scored each of the signals based on signal strength and frequency consistency. In addition, they also considered the drift effect. If some extraterrestrial civilization is sending signals to us, such a signal would experience what scientists call a Doppler drift. Essentially, the frequency we observe changes over time due to the relative motion between the transmitter and Earth. That means that the radio signal will slide in frequency instead of staying fixed. This could be caused by the fact that the planet is spinning, or the transmitter could be located on a satellite or space station orbiting the planet. In addition, the entire planet is orbiting its star, which causes slow changes in the frequency, but over a much larger frequency range. Therefore, signals were also scored based on Doppler drift matching expected extraterrestrial behavior. Finally, they scored signals based on repeat detections from the same sky position. An extraterrestrial signal should come from a fixed point in the sky and appear again when we point our antennas at the same location. If a signal is detected, but it doesn't show up again in the same place, it is more than likely that this wasn't a real deal, as planets around another star have stable positions in the sky. Each candidate signal then ends up with a score that is inversely proportional to the probability of the signal being a random noise. The lower the score, the more interesting the signal. Based on the score system just discussed, algorithms processed the 12 billion detections and reduced the sample to about 20 million candidates. To validate the algorithms, the team injected artificial ET signals, referred to as birthdays. If the system indeed detected one of those signals, then the team had some confidence that the process would uncover a similar extraterrestrial signal. The most interesting 1,000 signals were then manually examined by experts trained to distinguish ET signals from noise and RFI that weren't able to be detected by the algorithms. This produced 200 strong candidate signals, and out of those 200, the best 100 most promising candidates were selected to be reobserved with the current largest radio telescope in the world, the Chinese 500 Mira Aperture Spherical Radio Telescope, or FAST telescope. This telescope was selected as it is the only telescope in the world that has the necessary sensitivity to check the SETI at Home's candidates. 23 hours of dedicated observing time on FAST have been granted. After 20 years, billions of signals and millions of computers, what did we actually find? We hope to see the results of these reobservations very soon, but unfortunately, it is more than likely that we end up with nothing. Most of these signals are probably the result of human radio frequency interference that, regardless all of the work that has been done, were still able not to be picked up by the algorithms and the manual labor of the SETI team. And this is exactly why signals like the wow signal remain so fascinating, because they passed many of these filters and still haven't been fully explained. If you haven't seen the video about the wow signal, I highly recommend you to check it out. Is this discouraging or disappointing? Absolutely not. In science, a negative result is also a good result. SETI at Home is the most comprehensive survey ever done to find extraterrestrial signals and has significantly reduced the search space where alien signals could be hiding. But SETI at Home didn't just search for aliens. It changed how humanity does science. It started the whole citizen science revolution we are seeing today, involving regular people interested in contributing their time and equipment to the advancement of science. The platform developed specifically for this project, the Boeing software, allows home computers to be used as a part of a distributed computing platform that enables researchers to utilize processing resources of personal devices to analyze their data. Boeing is now being used in many areas for projects in medicine, molecular biology, mathematics, linguistics, climatology, environmental sciences, and of course, astrophysics. What is left for this project? Well, a lot. In an interview at the SETI Institute, which I will link in the description, Eric Corpella, one of the scientists part of the original SETI at Home project, mentioned that they still need to analyze the 1.2 petabytes of data from different angles, using new techniques and approaches. So, with new advancements in AI and machine learning, better filters can be developed, and perhaps we will finally hear about that elusive signal from an extraterrestrial intelligence. And if we do get to receive one of those signals, will we be able to recognize it? We talked about this topic on my video Communicating with Aliens, a Hail Mary task. I invite you to check it out. Thank you for watching and being part of this community. That's it for now, and remember, the truth is out there.